So today it's day 16. Today I was able to record much earlier because in the past days I was awake like at 3 a.m. But yeah, today I mostly work on two main things. The first one was reading this paper about conformal prediction, and the second one it's this one about um, about about a data set to evaluate LLMs, but it's more than that. Let's start by the first one. In this one, this paper, it's a good introduction to conformal prediction, which in essence it's a way of changing the model in order to predict instead of a single label like a set. That's it. So for example, we have a convolutional neural network that you give as input time some images, and as output it gives a softmax vector, right? And what we do normally is that we take the label that says with highest probability and we classify the label as this. And so if we have this image of a squirrel, we look like at the softmax as the vector and says, you know what, it's 99% squirrel and all the others are mostly zero, so let's output a squirrel. All right. But the way we do it in conformal prediction is that we define the rule in order to output not only a single prediction but a set if necessary. So for example, in this case, in the third image, if it's not entirely sure if the image is a squirrel, then it's gonna output maybe the first two labels like marmot or fox squirrel. So now the question becomes, how do you which rule do you use? What is the nature of this rule? And there are like many different rules that you can use. It also depends if you do classification or regression, but the intuition remains the same. And it's mainly you use a score, you computed the score and select a percentile. In this way you can assure that the probability of the true label being on the set that you are giving as output is going to be greater than 1 minus alpha. If you select n plus 1 times alpha quantiles. All right, so this is it. What else? It's important. This looks a little bit like this in regression. The only thing in regression is we are not only interested in this, but rather in like a conditional coverage. The coverage is this, what I'm saying, is this probability that I'm saying, like the probability that the true label is within the set of the output, the output set that you're saying. But the coverage, it's different for each class, for example. So you can try to set up a score if you want it, because the output of the model could be better, have some coverage for some classes, but the worst coverage for other classes. So depending on your score, you can optimize for average coverage, and that's sometimes not the best, right? You want something more uniform to be able to predict, to have a good coverage in all different labels. You can optimize for that, or you can optimize for sizes, right? There are many different things. And what else? Yeah, in regression, you want to optimize for a particular value of x. For example, I don't know, you are talking about houses, prices of houses. Then instead of saying that my prediction is going to be plus minus 100, I mean, it makes sense for small values or for values within a certain range. But once it increases, you kind of expect that the uncertainty also increases. So it's dependent of the input x. So you have to take this into account. And what else? And there's also a way of evaluating conformal prediction. Like, how do you know if your coverage is what it's supposed to be, etc. Because you are making like a hidden assumption. That is that the data that you will predict is going to be the similar as you're making the calibration set, and obviously this is not true. So now the question becomes, what would be, so if the coverage is a function of the data, then what is the nature of the coverage? I mean, it's a random variable. So what is the distribution of this random variable? And it's a beta distribution. So this is very interesting. But yeah, so if it's a beta distribution, on what depends the distribution? And most importantly, it depends on the size of the calibration set. And I think it's very intuitive, because you can think about it as, if I calibrate the data with small samples, then I could have very high variance on the coverage. I can, if I try to see if the true lies within the output set for a new data, it's not exactly gonna match, because it's a small sample. But as we increase the sample, also the amount of variance within the coverage will diminish. And that's it. That's like the intuition. And there are like two different types of metrics: size and feature stratified metrics. And we can sample the coverage using bootstrapping, for example. And there is like just one trick that you can use for the bootstrapping, which is you don't need to compute the inference of the model at each like sampling, but rather you compute it just once and sampling within the scores. That's it. And for this paper, this one was about LLMs, like the creation, the presentation of an LLM, and it's describing a really interesting phenomenon, which is, in this paper, is described as hive mind, which is, you have questions, open-ended questions, like for example, give me a metaphor about time. So these open-ended questions are not, cannot be measured as true or false, right? There is not that like a strict classification if it's right or wrong. So we expect as humans that a model, we expect the models to be creative, right? So we want different answers for open-ended questions. And the problem that they outline here is that even in open-ended questions, the model tend to produce the same output, and in two types of way within the same model. So if you ask an open-ended question many different times and in different ways, like, you're gonna get the same type of answer. And if you do it for different models, and that's the interesting part, you're also getting the similar type of answer. So it seems that the underlying data itself, it's what the models are like learning. If they share the same data, then they will share the same answers. So there are like a couple of things that they can change. One is the data. Another one is it's like the training. One, I would say, is like the pre-training, which is what I said about the data. Another one is like the alignment, because all of them are being aligned in the same way, like to be, I don't know, to behave in a specific way, right? And yeah, and there are like a couple of examples. Like if you ask, write a metaphor about time, most of them describe it as a metaphor. So the way the data set, it's a way to benchmark the creativity of the LLMs, and it's mostly a call for action and saying we need to address this problem of the LLMs not being able to produce different answers, especially for the open-ended questions. And yeah, that's it.